It's a liquid. It's a liquid because once it's been compressed, it's really, really cold. And then once you compress something, once you get something into a liquid state, it doesn't just instantly evaporate. For example, if you know that, so if you so I'm going to take a little liquid nitrogen and pour it on the table. It's not working, so let me pour it this way. Just put a drop on the table. And what I see is lots of little tiny balls. Let me put something in there. Let's suppose I put in, I want to start slow. Piece of banana. Now, to liquid nitrogen, has everybody signed in? How many? Has everyone signed in?
We're missing a few.
Sign me in. I forgot. My bad.
What's your name again?
Very funny Topia.
Put some banana in
Yeah,
there.
we're missing like 7 people.
So what's going on now? What's going on? I put some banana in the liquid nitrogen, and you see what's coming out? What's going on when I put the banana in the liquid nitrogen? Yes?
The banana's boiling with the nitrogen?
The banana is heating up the nitrogen. And as a result, the banana is getting colder, and the liquid nitrogen is staying the same temperature. Okay? And little by little, it's going to boil it, but and the banana's properties are going to change. It's so cold. It's so cold. Now, once the liquid nitrogen has sort of stopped boiling, it's not boiling as much. I'm going to bring it over here so I can. Then I know that the banana has reached that same temperature as the liquid nitrogen. It's sort of reached a steady state now. Remember, this was a mushy banana. I don't want to, I'll take a piece of paper. This was a mushy banana, right? It's now like it's not frozen. In fact, where's my hammer?
It's over here.
I need a pair of goggles. So there's a pair right there. Can you need a pair of goggles?
Yeah, should there be people in the front?
People in the front, grab some goggles, yeah.
Oh, that's good.
Anyone in the front couple of rows should have goggles. Everyone here, give her some, she's going to give you some goggles.
How many are there?
There's a whole bunch.
Toss me one.
Probably not.
So it's pretty hard.
Give me a second.
Oops. Okay, thank you. So basically we just froze, and it only need the first couple of rows. These two rows back, that'll be fine. Okay. Nice soft rows. I feel like a spaceman between the mask and the.
liquid nitrogen? It's like 100%.
What?
Is it 100%?
It's 100% nitrogen, yes. It's very pure.
Is it like expensive to get or?
So we just froze the rose. Now it's gonna, the petals will just warm back up. I want to get a few other things going. One of the fun things that's gonna take a little while is to put a golf ball in liquid nitrogen. It's supposed to have some interesting effects. So now this, you can touch it as long as you're careful. Certain things you don't want to touch. So my plan is to show you a bunch of different things, like the rose. I wonder if this will work. Take this out. I didn't have a big round, a big deep dish. So I'm going to try this. Let's see. That's pretty good. So, I've put some helium balloons. Let's cut it. I'll put the helium in the liquid nitrogen. And what's going to happen now when I put the helium balloon in the liquid nitrogen?
Shrink. Would it shrink?
It's going to shrink. As time goes on, the helium that's in contact with the nitrogen is going to cool off. I'm going to need to hold something above it. Okay. Well, it's gotten to the point where it's no longer big enough to lift up, so it shrunk to that point. But there's still helium in the balloon. And let's leave it there for a while and let it cool off the helium. All right. I have a teapot. I want to pour liquid nitrogen in the teapot. You know, this is a whistling teapot. How does it work? How does the whistling teapot work? Yes, Rohan?
When something's boiling inside it, the gas is escaping, goes through a small hole which makes it.
Okay. So what's going to happen if I pour liquid nitrogen into this? Well, nothing will happen if I don't open it. It would have been better if I had like a projection camera on the ceiling. Next time I do that, you have to come home from college to help me out with it. See how it's working? As far as the liquid nitrogen is concerned, this is super hot, right? Liquid nitrogen is negative 320 degrees Fahrenheit. So if this was like water, and it was, imagine this is water and it's 321 degrees above the boiling temperature. Just imagine how hot this container feels to the, sorry, I see you reacting, I apologize, but when I went to the dollar store to buy this, there was one that said it had a pleasant sound. Maybe I should have bought that. I didn't want to spend the extra money. So, you're getting used to it. Right. We'll pour the rest of it back in here, because it's taking a while for this balloon to really shrink. Hold it down. I didn't realize this takes so long. This part takes so long. All right. So, this is always a fun one. So I have a bouncy ball, and I'm cooling it off. It's boiling like crazy. Apparently this is not going to be so fast because boiling like crazy. I'm boiling a bouncy ball. And it's which means that it's cooling off the ball to liquid nitrogen temperature. You can see the steam forming on top. I don't know if you can see it or not. Okay. That's liquid nitrogen steam. So one year I went to buy liquid nitrogen for a demonstration for students, and I couldn't figure out a way to get the liquid nitrogen back to. So I said, I just bought the container like this, and I said, all right, I'll just strap it in my car, in a seat next to me, with a seat belt. What happened? I guess that didn't work. All right, it didn't shrink enough. All right, we'll have to see. I'll try with the other. I'm not going to get that down so easily. Anyway, so I said, I'll just strap it in, and it was fine. I did make it survive. But, you know, they did say, look, if it was to fall over, the whole car would fill with nitrogen gas and would exclude the oxygen. It would be very, very dangerous. Plus, you won't be able to, with all the steam that would come, you wouldn't be able to see out the window. I said, but I need to do this for the sake of science. So they just... This was a really horrible place. I went to this place to buy liquid nitrogen. It was in southern Jersey, and it was a truck place, and it was, you know, they sold gas, and all these truckers would come in, and the guy started yelling at me. He said, you know, he poured the liquid nitrogen thing and it steamed up. He goes, you're not supposed to do this. It's the wrong size. You're wasting a lot of nitrogen. I said, I'm sorry. I'm just a teacher, and I'm not really getting funded for this. I'm just going to do this myself. Oh, then it became really nice. But there was a sign on the side of the building. And it said, no urinating on the side of the building. That's what it said. Really. That's what it said. No urinating. It was not permitted to urinate on the side. Where's my, here. Everybody has goggles on now. Yes? No, I want the people in the front to have goggles on, because I'm about to do something that could be dangerous. So put on your goggles. Put on goggles, please. Goggles. So I showed you this bouncy ball. Should I do it on the floor or on the table? Everyone has goggles on. Get goggles, get goggles.
Yes.
Oh, it did.
Oh, there it goes. Got one good rigid body bounce.
Yeah.
Well, the whole.
Those aren't all of them. Yeah.
As long as you hold it lightly and you don't really squeeze it, it's not that bad.
Can we hold it?
No. Maybe I can try for it. Put your goggles back on. We'll try for another bounce. See if it's still cold enough. Yeah, you too. Yeah.
Oh, no.
These are the good ones, like the ones that have the screen or glasses.
It's warming back up and okay. It's too big. Let me pour it into a little container first. So when I was a graduate student, I did my thesis work at Bell Labs while I was a student at Princeton, and there was a guy.
Is that like the local community college?
Local community. Yeah, exactly. Anyway, so there was a guy there who was like an assistant staff member. And he was above my level, but he wasn't, anyway, he was given the task.
Yeah, I was about to say.
This is my other. Taking longer than I thought it would. Maybe I'm out of liquid nitrogen. Maybe I should put more in. Yeah, it looks like I'm out. All right, let's try it. I thought it was going to be flying around the room by now. I must have used up the liquid nitrogen. Let's try that again. So he was told, we're going to make a new lab. His name was Rick. I never forget him. Nice guy, but he was a real down-to-earth kind of guy. He never, and he heard his own drummer. He was really, really good at finding solutions to simple mechanical problems. And he did it whatever way appealed to him. So they told him, we have to remake the lab. He said, oh, so I'll remove the floor. He said, all right, how are you going to do that? He got a huge container of liquid nitrogen. It was like this high. And he just opened up the valve and would pour, and just let it pour on the floor over and over again. And it basically cracked, the tiles started to crack, and then he removed all the tiles. Maybe I need some more. I guess it's not doing what I expected it to do. It's staying cold. That's because I'm using root beer. I guess. Let's try this other experiment then. We'll pour a little liquid nitrogen in the balloon.
Dr. Kaplan. Is solid nitrogen dry ice?
No, you can't get solid nitrogen. There is no solid nitrogen.
So what's dry
You'd
ice?
have to press, the only way you can make solid nitrogen is take liquid nitrogen and compress it under pressure. I guess this balloon really stretches. I was expecting it to explode or something dramatic, and all I'm getting is a bigger balloon. It's not doing what I wanted it to do. Yeah, I had a second glove. Could somebody hand me? I think there's a. I don't know where my other mitt. I brought 2 mitts. Hot mitts. Do you see it over there? Or over here? Where did I put it? I need a second hand. Oh, here it is. Yeah, I got it. But that's interesting, but it's not that much more dramatic than what you would have gotten from just taking, blowing up a balloon and letting it go. It's just, yes.
Do you guys have high wall container?
Sorry, I can't hear you very well.
Have a higher wall container.
In this?
Yeah.
I don't have anything else. It was supposed to be that if you put a golf ball in liquid nitrogen, it will like come apart. I also got this ball. This is going to take quite a while to cool down. This is a solid ball. So I don't know if I want to try that or not. But let me pour some liquid nitrogen and let's see what happens with the golf ball, because I read that golf balls have some really interesting properties when you get them cold enough. All right, it's boiling. It's cooking the ball. I hear it cracking. You can see a lot of steam is coming off. Yeah, it is cracking the ball. Oh yeah, what you can't see, maybe you should bring your camera right over here and look inside. Oh, but no one else can see it anyway.
No,
I don't have it set up.
see another good view.
All right, so what you can see is the skin on the ball is cracking. It's almost like when you peel an egg. Like when you have a hard-boiled egg and then it cracks when it's ready to peel the hard-boiled egg. So dry ice is frozen carbon dioxide. Okay, not frozen nitrogen. It's much warmer. It's hundreds of degrees more, I think, than liquid nitrogen. Liquid nitrogen is 77 degrees Kelvin. Okay, and liquid helium is around 4 degrees Kelvin. So if you try to get to very low temperatures, people have gotten to micro Kelvin. That means 1/1,000,000th of a degree, approximately. Now, it's very, very difficult to even define what that means and describe what that means. You have to really be a physicist to understand that subtlety. The cosmic background, the outer space, is 3 degrees Kelvin. So liquid helium is almost the same temperature as the temperature of outer space. The temperature of outer space. And this is much, much hotter. Okay. And there's some interesting things that it's not cold to show you. When things get really cold, certain things change. One of the things that changes for certain materials is they become superconducting. Have you ever heard of that? Superconducting. And basically what that means is that the resistance essentially goes to zero. Now I don't have a superconductor, but some really interesting effects happen when you pin magnetic fields and things like that. When you can get things that just hover there with a superconducting magnet. Okay. It's gotten a lot harder. Everybody wearing goggles? Didn't work. It's still too strong. It didn't work. So I read about this one. Okay. One of the things I thought that would be interesting to try. Oh, I have this thing. Now I don't know if it's going to work, but it came with the room. I haven't had a chance to try this out in advance. So I have a bowl with water in a sealed container and another bowl with water. I think I've seen this done once. I'm going to put this in the water. See what that does. In principle, it should be condensing the water out of all the moisture should be condensing out so that we'll get a vacuum in there eventually, if this works. And what should happen is this should start to boil. Doesn't mean it's getting hot, it just means that there's no gas pressure, but it's not working.
Is that glass or plastic?
It's glass.
Wouldn't the glass break in that temperature?
No, should be all right. Supposed to be made for that purpose. It's not working. The water is boiling. The nitrogen is boiling, so it's still cooling down. What should happen is all the gas that's in here should condense onto the bottom surface, and as soon as you have no gas above this, the one above it should start to boil. Let me put a little bit more liquid nitrogen in there because it's not really. It's either the better way. I really should get clear bowls so you can see what's going on. All right, if I do this again, I'll set up a camera system so you can see into the. I can feel it getting colder now. Is anything happening?
Yeah. Top frozen.
What?
Is the top frozen?
Did you see anything?
Top frozen.
The top broke?
Froze.
It froze. Oh, yeah. Okay. Oh, okay. That's what it did. It just froze. I was hoping something else was going to happen. You saw it freeze?
Yeah.
I didn't see it.
Froze like instantly.
Instantly?
Yeah, like pretty instantly.
Oh, wow.
Well, not like as soon as you put it in, but like it goes very quickly.
Okay, so let's let it warm up, and then we'll do it again. Place it over here. Okay. I got some springs. I brought some springs over. I Where did I put them? Just went and got some springs. Oh, here. So, I don't know what's gonna happen with this, but I thought it would be fun to see if the spring constant, which basically, the spring constant, anyone know what a spring constant is? Anybody know what a spring constant is?
This is the amount of newtons we need to stretch at 1 meter.
That's right, it's newtons per meter. Thank you. So I have, to give you a sense of what this thing can do, what this particular spring is like, I grab the spring, put this weight on it. I don't know what's going to happen here, but I thought it would be interesting to see if the spring constant changes when you get it really cold. So that's how much it stretches now. Okay? So let's see what happens if I let this thing reach liquid nitrogen temperature. So it's boiling now. It's cooling off. Stop. I guess it reached liquid nitrogen temperature. Or almost, it's still boiling a little. Let's see if it was any perceptible. I don't know if it's going to work or not. Doesn't seem that different, does it? Maybe I should, maybe because it warmed up too rapidly when I put the other one in contact with it. Yeah, look how cold, how fast it warmed up. Because when I put it back in, it boiled again. It's not that different, is it? All right. I would have expected that the spring constant would have gotten stronger, part, but the same. I don't want to put the mass in because that'll just boil forever. Okay. What else did I have in mind? One of the things I've been wondering about. I wonder what would happen if I put a mask in. I have no idea what's going to happen. Something I never had years ago when I did this.
Dr. Chapman, I gotta go.
Okay.
Thank you so much.
Does anybody have something you'd like to suggest that I try? Because I was thinking that I'd leave
Dr. Chapman, try it.
a phone, yeah, a cell phone. I don't think that's a good idea. Well, it doesn't get to the point where it doesn't break. Let's put one of these balls in. This is a much stiffer ball. It's solid all the way through. Let's see what that does. It's cooling down pretty quick. Yes?
Can you do it again where you just pour some on the table?
What?
Can you just do it again where you pour some on just the table?
Sure, I can do that.
Or maybe the floor so you can see better, if it doesn't crack the top.
Well, it's white though, you probably won't be able to see it on the floor.
Should I pour some on the floor?
You can really see it.
Nice.
The floor is a little bit dirty.
Yeah.
Just a little bit.
That's so cool.
What does it do?
Pushes all the dirt away.
Well, is that a good way to clean a floor or not?
I mean, it's not efficient, but
I mean, don't use too much of it at once, because then you don't have it anymore.
right.
Which I suppose is clean in its own way, but... You can't unless you put it on the floor. Exactly.
So put some more on the floor?
Oh my god.
There's glass crushes.
It basically, what happens is, there's no friction, right? Because it forms a little layer of gas. Then as it makes contact with the floor, you get a ball of liquid hovering on a compressed nitrogen gas. And the gas keeps, as long as there's liquid there, the gas keeps getting regenerated, and it's almost completely frictionless. And so you get like a little frictionless ball swinging around. That's usually the thing that kids like the most, is that. So maybe I'll make some.